This video is to be used in conjunction with the 6000 family products. It is a demonstration of the capabilities of the MotionArchitect software. In viewing this video, it is assumed that MotionArchitect is installed and the system is wired correctly. MotionArchitect is a Microsoft Windows application development system to help you design, develop, and debug programs for the 6000 family products. Our first step is to enter MotionArchitect through Windows. There are 6 main modules which can be seen here. They are Product, Setup, Editor, Terminal, Panel, and Help. We will be discussing each of these in depth. Our first step is to enter the Product module. Here we will select what product we are using. If we click on Selection, we can see our options. If we select one, a simple description can be seen at the bottom of the box. It should be noted that if the 6250 servo controller is chosen, another module called Utilities appears. Within this module, the tuning aids can be found. This is an additional option of MotionArchitect which must be purchased. Now we'll go back to Product. If we select Defaults, we can see the default product which will be assumed upon entering MotionArchitect. Today we will be using the 6200. The next module we will enter is the Setup. This allows controller code to be generated automatically with the use of setup parameters. Now that we have entered Setup, we will select Configure. Here we will choose Define Program, which will begin and end a program. Let's call this Duck94. If we were to skip to Generate, we can see some code. After generating, we are asked if we'd like to save. From here, we will go back to Configure. Let's select Participating Axes. With this, we can see how MotionArchitect will assume the default for the product being used. For our example, the 6200 controls 2 axes. As we step through Configure, we can see Step Pulse Width, which gives us the option to adjust it. The step pulse width should be configured to meet the minimum step input pulse width requirement of the motor drive attached. We will keep this at the default values. Consult your user guide for more information. We should note that if you do not choose a configure selection, the default will be assumed, not appear in the code, and not have a check mark next to it. In the memory selection, we can rearrange the memory allocation. For example, if we were not going to contour, we could put the path storage into program storage. We will leave these at the defaults. The drive option allows us to change our drive resolution and drive fault level for each axis. Our setup contains OEM drives, so we must switch our fault level to high on both axes. Since we are using microstepping drives, we will leave our resolution. Consult your user guide for specifics of your application. Next, we have scaling. Here we can adjust the scaling factors. This allows the user to program in units specific to their application. Here we will change our distance scaling from 1 to 25,000 on both axes. This internally multiplies, so we will input revolutions rather than steps. The incremental absolute option allows the user to choose either for each axis. We will leave these at incremental, which is the default. The limits selection allows us to change or set hard limits, soft limits, and home limits. We will enter hard limits and disable both axes in the clockwise and counterclockwise direction. With the limits disabled, motion will not be restricted. The encoder option allows the system to be configured with an encoder. Position maintenance and/or stall detection can be enabled. Since we are not using encoders, we will cancel from this menu. Next, we will set up some outputs. We will make output 1 a motion detection output. If any axis is moving, output 1 will be on, and if not moving, it will be off. Now we will set output 2. This is done by clicking on the arrow and moving to output 2. It then appears in the main box, and we will give it a program in progress function. We will assume output 3 as a programmable output, which can be seen later. Let's note that the outputs can be assigned to the functions at the bottom of the screen. The faded gray functions are not applicable for our setup. We will accept these outputs by clicking OK. As we enter inputs, we can see how similar it is to the outputs. The configuring is the same with the exceptions of the functions available. Let's change input 1 from a programmable input to a kill input. The triggers are configured exactly the same, and we will not be using one, so we will cancel from this menu. We won't be configuring analog today either, but it gives the user the capability of setting the joystick motion, joystick electronics, or the feed rate override. Now we will generate the code by simply clicking on Generate. When completed, we will save as duck94. Take note of how quickly the code was generated. It is fully commented and separated into different options. Let's close Setup window and go to the editor. Here we can create, edit, search, and navigate. We will be editing the program we just configured. First, we go to File and select Open. Now we will find the duck94 file. Please note that once you are in the editor, the file names end in .prg. While we were in setup, the configured files ended in .cfg. Now we click OK and enlarge the screen. If we move to the bottom of the program, we will create a simple move. This move will have a normal move and a continuous move. We will also be using the inputs and outputs we just configured. Remember that we defined output 3 as a programmable output. So we will have this turn on and off in between the defined move and the continuous move. Next, we save the file. Shrink the editor window and open Terminal. The terminal allows us to send our commands to the controller. Now that we are in the terminal, we must connect under the Transfers menu. Then send the file duck94. Now we will run the program by typing duck94. Recall that output 1 is motion, output 2 is program in progress. When we are running in continuous mode, we will toggle input 1 to kill the program. Let's run it again to verify we know what is going on. Now we will disconnect in Terminal and proceed by closing the editor and Terminal. Next, we enter the panel module. This allows you to test your controller programs with your own operator test panel. Our first step is to click on Transfer and connect. We enter Transfer again and send our DEC 94 program. Next, we go into Displays to begin Input Panel creation. Select New I/O Display, then click I/O, which is the directions given, and Programmable Inputs. The steps for this process are, first, take off the Show Programmable Input box, click Duplicate, click Show and OK. Select the input being used. Write a description. Select the Show Input box and OK. The value of input 1 is shown. Next, we will create our output panel. Let's click on Display, then click New I/O Display. Select I/O and Programmable Outputs. This is the same procedure as for the input panel. The steps are, take off the Show Programmable Output box, click Duplicate, click Show and OK, select the output being used, write a description, and select the Show Programmable Output box. In this case, we have more outputs, so we don't need to select OK. Rather, we scroll to Output 2, we change the description, click the Show Programmable Output box. Let's repeat this for Output 3. And complete this by selecting OK. Now we go back into Display and choose Motion Display. Select Motion and Motor Position. We will repeat the duplicating procedure done earlier. We want to monitor the position in revolutions, so we will adjust the scaling and change the description. Next, we scroll and repeat for axis 2. End in Display by clicking OK. Once again, we go to Display, and this time choose New Status Display. Select Status menu, click Axis Status. If we click the Axis box, we can see that it defaults to Axis 1 and 2. Repeat the duplicate procedure to show bit 1 moving status and bit 2 direction status. Select the Show box and OK. Finally, we want to have a communication or terminal display. Once again, we go to Display and choose New COM Display. Now that we have our desired panels, let's arrange them by choosing Windows and tiling horizontally. Let's put our mouse in the communication box and type pset command to see our motor position reset. Now let's type DEC 94 to run our program. Observe the panels updating. Once again, we will toggle input 1 to kill, and we can see this in our input panel. Another fancy feature of MotionArchitect is its button capabilities. Let's see this in action. Select Settings and define Buttons. We will edit button 1 by changing B1-1 to Run. Then, in the command column, type duck94, which is a 6000 code command. Click OK. By doing this, we can run duck94 by clicking on Run rather than typing it again in the communication panel. We will again kill the program by toggling input 1. You can use 4 levels of buttons with 8 buttons each, for a total of 32 buttons. By choosing the visible buttons at each level, all will be seen. We have arranged another panel of buttons that goes a little more in depth. We will pull this up by exiting and re-entering panel. We will now open the file. As it tells us, we have to reconnect. Let's look at our button definitions. Notice we have a string of commands separated by the colon delimiter. In this case, we are not using a stored program, and nothing has to be sent. Let's see these buttons work. Notice the panels updating as the movement occurs. Let's close the panel module. Our last module is the help. This allows us to have online help screens which are available regarding 6000 software reference and MotionArchitect operation. The keys help and help index are specific to each module. Consult your user guide for more information. We hope this has been useful.